My name is Boaz Brudner. As Javi mentioned, I'm the head of Innovyze SaaS engineering, AI, and architecture. Today, I will talk about building scalable SaaS product portfolios the right way. And I'll start with a quote. Sam Altman has been in the news quite a bit. Of course, the CEO of OpenAI and Y Combinator as well. Really speaks a lot about being fast. So speed is a critical factor in our ability to be competitive in any kind of application that we build, any kind of service that we build. Um, and it is one of the differentiators between strong companies and companies that sometimes lag behind. So a little bit about myself. So I'm a veteran of Cisco and Zillow. Been around software engineering since the early 2000s. And ever since 2014, I've been building with larger and larger teams, enterprise scale SaaS solutions. Uh, Vast majority of those have been on AWS. Uh, Early 2020, I joined Innovyze as a VP of engineering. Innovyze was acquired by Autodesk midway through 2021, and I'm still in the same position at Innovyze, which is now part of Autodesk, um, leading the SaaS engineering organization, the AI, artificial intelligence teams, so data scientists, machine learning engineers, and the overall architecture for the SaaS side within this organization. So, jumping in, I'll start by talking about what Innovyze is, and that will give some perspective on the size of the SaaS applications that we build. I'll talk also about some of the SaaS applications that our customers use. But I'll start first of all with Innovyze. Innovyze has been around for more than 30 years, building software for water professionals, starting from uh, uh, water structures, storm, sewer, and flood, drainage design, water distribution software, sewer networks software, and of course, water and wastewater treatment software. And we deal with these types of systems in various different levels. The first level is design and hydraulic model. So all of these systems, they need to be designed. Engineers need the ability to design these systems accurately. So provide software for engineers to design these systems. Also, a critical part of designing of each kind of systems of that sort is the ability to simulate the behavior of water within these systems to make sure that the capacity of these systems fits what they need to do and the amount of water and water behavior that it needs to handle. The second thing is asset management, which we'll touch a little bit more later. And that is the ability for asset managers within these various systems or within these various water industries to manage the actual assets within those. So when I talk about assets, I'm talking about pipes, pumps, manholes, things of this sort, figuring out how to best manage these pieces to make sure that they get the right maintenance when it needs it. And last is operational analytics. So operating the day-to-day operations of these systems, making sure they operate at their right capacity, making sure that customers or end consumers get the service that they need to get from these various systems. So diving in a little bit towards what our customers need from us. We always start from the problems of our customers and making sure that we provide software that makes their work just that a little bit easier and better for their end consumer. So our customers face an increase in demand to keep their service quality at top game. So we provide software to ensure proper asset performance. Water scarcity is becoming an ever increasing problem for our customers as the overall population of the world grows. So we help reduce water leakage from these systems. And of course, because of everything that we discussed so far, regulators are getting into the space more and more, regulating the services, the water scarcity, water quality, and environment in general. So our customers need the ability to monitor and report what they're doing in real time and historically to make sure that they meet these regulators' requirements throughout their operations. So just taking a step back and explaining what kind of software Innovyze has been building. So on the left side, there are four products that Innovyze has built for many years. Those are desktop-based products that our customers love and have been using for all of these years. Info Drainage for drainage design, InfoWorks ICM for storm sewer flood design and simulation. And for water distribution, we actually have two separate desktop products, one InfoWorks WS Pro and Info Water Pro, two products that are geared towards water distribution. So getting water from the source to people's homes or factories, plants, industries, and so forth. The three on the left, as I mentioned, are desktop applications. Now, from around mid 2019, Innovyze was trying to figure out what can we do to serve our customers better. And the decision was made, look, we need to create a SaaS solution or a set of SaaS solutions to provide our customers with additional services and capabilities to serve their customers even further. So there are three new products that the Innovyze has put out in the market since then. First one is for asset management, Info360 Asset. Again, a software for asset managers. The two additional ones are for operational analytics operators. The first one is Info360 Insight for water distribution or water networks. So customers like water utilities, water municipalities to operate their infrastructure on a day-to-day basis. And finally, the latest addition to this family is just joined in September of 2022, Info360 Plant, which is a product geared towards operator of water and wastewater treatment plants to allow the operators to effectively and efficiently operate their treatment plants. So I'll touch briefly on these two products, on some of these products, on two products specifically, on Info360 Insight, on Info360 Asset. And the main goal for me here is not to really dive into these products in a very deep way, but really for you to get a sense of the depth and breadth of these products. And then we can talk about the speed and how we created the speed of development that we have achieved with our development processes. So let's start with Info360 Insight. Info360 Insight is a full-blown operational analytics solution for water utilities. So it is geared towards minimizing energy cost, minimizing water loss, preventing water leakage as much as possible. It serves as a unified incident dashboard for these utilities and allows our customers to report and communicate their work based on actual data that their various systems provide. Now, as you can see on the right side, the system has a lot of data that it provides to the operator. It's all real time, has lots of tools that make their work more efficient, faster, and more accurate. With that, I'll touch a little bit more about the other products that we'll talk about today, and that is Info360 Asset. Info360 Asset, as I mentioned, has a different persona in its objective, and that is the asset managers. Now, what asset managers do, water utilities, storm sewer flood utilities, and the likes, they actually manage the overall health of the infrastructure that they manage. So, for example, in sewer systems, companies invest a lot of effort to continuously inspect these systems. So, for example, in a sewer line, what companies do is they have crews going around the various parts of their system, dropping in sort of like a remote control cars with cameras on top, and these remote control cars or systems, they just go through the sewer lines and inspect these sewer lines. This system, Info 360, provides an ability to upload these sets of videos, provide easy access for inspector to provide the actual inspection, because what video is one thing, there is an actual inspection that goes into that to specify where they see cracks, collapses, problems within these pipes, and so forth. Now, the other side is we mentioned the side of the inspector, so a person would be able to upload and provide that information. But then the other side is the asset manager. The asset manager needs an ability to easily view all of these inspections in very much a detailed level to understand what is happening at anywhere in their system. So they have a map, they can dig in through that, they can look at any kind of asset and understand what is happening within these assets based on the last inspection that has occurred. They can even look at historical inspection for these assets to see the progression of problems. Was there a problem a year ago? Was there a problem 2 years ago? Now they get a full understanding if there is a fast progression to a problem that they need to deal with. And then finally, Info 360 Asset provides the ability to figure out, okay, there is a condition of a pipe. What do we need to do about it? Or whether or not we need to do something right away, or can it wait for a later time? Because the reality is resources one is inspect, but also to correct problems is scarce. And asset managers need to make sure that they divert funds and capacity of their personnel to the right places. So the platform provides the ability to figure out the likelihood of a failure. So what is the likelihood of a specific pipe, for example, to re-fail based on the inspections that have occurred, the results of the inspection that have occurred? What is the consequence of a failure of a pipe or a manhole? So, for example, if a pipe is very close to a hospital, that will constitute a significant problem if a problem were to occur. All of these factors go into the decision making of an asset manager to address a specific defect. So now going back to the development process and also talking about speed, we're talking about speed. So one of the things that I wanted to kind of provide a little bit of context is the timeline that we're talking about. So all of this was kicked off in May of 2020. Started off 2020 with hire some personnel. Even myself, I joined around February of 2020. But really, first line of code was developed on May of 2020. We assembled quickly a team with about 25% of the SaaS team coming in from our desktop development organization. Now, do remember that they still had a great set of desktop developers still continuing to manage our long-term desktop application, but 25% of our SaaS team was comprised of seasoned desktop developers who are also water domain experts. They really understand this environment. They really understand what our customers look for when they seek out a solution. But then we augmented this with about 75% of hiring of AWS SaaS experts. And we were very particular in hiring AWS SaaS experts. Now, I have to say that over time, 100% of our organization are AWS SaaS experts. I'm really proud to say that all of the engineers that we brought from various places within the company are by now AWS SaaS expert. A lot of them are with AWS certificates for solutions architect, and even a few are AWS certified solution architect professionals. We didn't want to wait for hiring to occur and to really onboard because it does take time. And we're talking about a team of close to 100 people. So we've actually bootstrapped the development back then in April and May of 2020 with external experts that we hired as professional services to really get going immediately. Our teams are located in the UK, US, Canada, Mexico, Australia, and various other places in the world. Just as a note, May 2020, really at the peak of the stay-at-home orders, everybody was remote. We were doing this while everybody was home. Now, in terms of timeline, started May 2020. The first MVP launch was March of 2021. Info360 Insight was the first product we put to market. So really, 10 months from the point of kickoff to the first MVP and a large scale MVP. This was not like a small MVP. It has quite a lot of features. And ever since then, these features have been adding up on the various products in multiple times a week. Then the other products that joined the Info360 family, Info360 Asset, 10 months from kickoff to MVP launch. Info360 Plant, really amazing, 6 months from kickoff to MVP launch. And along that time, we were actually acquired by Autodesk, and now we are part of Autodesk. So that gives you some perspective of the speed at which these products are coming to market and the addition of new products and capabilities as we move forward. So as you see, we do have a lot of focus on driving customer value fast. I would also argue that it's driving customer value at great quality. And as you'll see, everything that I mentioned in the next few slides actually contributes to moving fast, but also moving with great quality. So with that, let's talk briefly, and I'm not going to dive too much into this slide. I'll talk a little bit about what Info360 really is. So as I mentioned, the various products, of course, the products are what customers see. Info360 Asset, Info360 Insight, Info360 Plant. Those are the products that our customers actually see and deal with on a day-to-day basis. But the reality is that these products are built on top of a robust shared services platform that has various services that serve the various applications that run, such as maps. As you saw in previous slides, maps are used in almost all of our products. Alerting, the ability to alert on a problem or on some data. Identity, of course, so the ability to sign in, be part of a tenant or a team. That is also a shared service that is shared across all of our products. And so forth and so forth. Now, all of that is built on a very robust infrastructure, for example, for telemetry. So telemetry is the sensor data that our customers have in their systems. We need to be able to bring that in. So we've got a subsystem for telemetry. Analytics and business intelligence, that's a core piece of the products that we provide. And also one part that is very unique is that we didn't forget our desktop applications. We wanted to make sure that our desktop applications really see the benefit of a cloud solution. So we have something that we termed Innovyze Domain Services, which provides cloud services for desktop applications. So InfoWorks ICM, InfoWater Pro, InfoWorks WSPort, Info Drainage are products that run on desktop but can leverage an ever-increasing capability from the cloud. And of course, third-party integration services and all of our products are geared towards advanced AI and optimization capabilities. So that's an Info360 in a nutshell to explain how we view the world of developing SaaS, robust platforms and portfolios. So now moving forward from that, I wanted to start kind of touch on what were the guiding principles of this development. So the first part was that our CEO and CTO were really pushing to do it the right way. No shortcuts. No, okay, let's do something that will work for in the meantime. Lift and shift existing capabilities and just provide kind of a hybrid solution and so forth. The message was very clear. We want to build the best solutions out there to be cloud native and to be very capable and scalable so that our customers can uh, continue to use these products, and we will be able to continuously add capabilities to those without needing to do a lot of refactoring because we took some legacy components and so forth and created some shortcuts. So no shortcuts were done in the development of these products. It was really do it the right way, build cloud native solutions. We've got a platform plus product concept. I mentioned the platform in the previous slide. It's a wide platform for common services. So that allows us to, one is provide a very good customer experience. When they move between one product to the other, they actually see the same data but for geared towards a different persona. So if someone uses Info360 Insight and sees the overall pipes, pumps, reservoir within their network, their colleague in a different organization within the water utility, the asset manager sees the same exact thing, but from a perspective of an asset manager. So we can support multiple personas per customer that have different views of the data and different needs of the data and the systems themselves. They are very much connected and they can work together. Reuse and share of UX component. This is really critical from a user experience. The user experience is very much identical across the board. A persona that uses one of our products is very much capable of using any of the other products. It's familiar, it's known, they know where to look for things, and they are able to really jump in and use the product very quickly. And of course, the other part of reusing the UX component is speed. We do not need to rebuild UX components to work on different products. And of course, building once. So building once a service is really important that we in the just by the fact that we do not need to deploy and create services multiple times to serve multiple different products. So it's one shared service per different products. Now, another part that was really important for us, as I mentioned, the teams are roughly 100 people, slightly more by now. And we wanted to make sure that the various team members across the globe would be able to work very much independently. So the friction between the various teams would be minimal. And the best way that we found to do that is to really hone our architecture in a way that allows these teams to be very much independent, decoupled. And that is an event-driven architecture. Some of the architecture that you can build a SaaS portfolio in the cloud is based on API interaction. So one service calls another service through an API. That requires quite a bit of friction between the various teams, so coordination of API signatures and so forth. Event-driven architecture is very much geared towards communication and interaction between services via event messages that run on event buses. What does it mean? It means that one service can just send out the events or situation that it sees and does towards an event bus. Every other service or new services that need to do something with that data just listen to that event bus and they can do whatever they need to do. They're not tightly coupled. So teams do not need to really coordinate a lot on API signatures, interaction of scale and so forth and things like that. All of that is managed via event-driven architecture and really reduced significantly. So teams are able to deploy and run with their services as much as they need. I do recommend to dive into event-driven architecture because it really is a value add for such a portfolio. The second thing is thinking about the front end itself. The various front ends that we have follow a micro front end architecture. And what do I mean by that? In a standard architecture of front end, each team or each builder of a front end would build the full front end for their products using libraries and capabilities that other teams are building. But at the end of the day, it's one big front end. We chose to go with a very much a micro front end architecture, which allows our teams to actually build small component micro front end, which in runtime go and are fitted into the overall front end. So instead of teams having to work together with friction to coordinate when specific pieces are deployed to production or move forward and so forth, or maybe have one team that collects all that front end, all of our teams are very much independent. They are able to deal with their small pieces of the front end. And what the customer sees at the end of the day is a full scalable front end. But what actually happens is that this front end is comprised of multiple front ends from various teams. We choose AWS, and we were all in on AWS, just one cloud to make sure that we can get the maximum benefit that it can support natively. And I'll talk about some anti-patterns as I see when we talk about choosing a cloud provider. We also use Snowflake and MongoDB for our large-scale data store, in addition to Amazon DynamoDB. But these are very much Snowflake and MongoDB, very much managed services. We also have a mantra to really maximize embedding and integrating of services over building new services. So when we have a new feature requirement and we are set to build and architect that, the first question that we ask ourselves is, instead of building such a service, can we embed a service from a third party? Can we integrate a service from AWS or another third party before we get to build? And that has really allowed us to move fast instead of building all the various small pieces of our applications. One of those, for example, is Amazon IoT and the Amazon IoT ecosystem. A great deal of our telemetry infrastructure is built on the AWS IoT ecosystem so that we do not need to deal with building of these small building blocks for our system. The next bullet point, which is really important to kind of have it sink, is that we really rely on serverless and managed services as much as possible. And when I talk about serverless and managed services, I talk about, for example, the first part is compute. So compute capabilities are very much, I would say about 95% of our code run on AWS Lambda, which is a serverless compute function. Because that allows us to really be elastic at our scaling. We have minimum idle costs, so where a specific service does not run, it does not cost us. We don't pay for that runtime. And really, we minimize the DevOps overhead for these services. We don't need to patch them. We don't need to update them. They just work. And also, even further, they gradually become faster because just the third parties, for example, AWS in this case, makes them faster because they provide improvement to those. Not to mention that the cost usually is reduced over time for these services. The second thing is managed services. We really look into managed services. We do not want to manage any kind of clusters or any kind of virtual machine clustering and so forth. We really want to have our third parties, especially Amazon, but also others like MongoDB and Snowflake, to really manage the infrastructure for us so we do not need to deal with that. Now, I would say I mentioned 95% of our computation is done on Lambda. or business logic on Lambda. We do have cases where Lambda doesn't fit for various reasons, for size and for runtime and so forth. In this case, we leverage Amazon ECS, which is also a managed container cluster service, and we run containers on that. We do have a couple of virtual machines because sometimes containers just don't fit our unique use case, and we do have one or two virtual machines that run some legacy software that is gradually being phased out in favor of running on containers. So remember this: 95% Lambda, and then about 4% containers, and then the last 1% is running on virtual machines. That really minimizing our DevOps overhead. Continuing with that, when I spoke about the Info 360 as a platform or a shared services infrastructure, I wanted to make sure that you also understood how we treat that platform and how we decide which pieces of that platform we build at any given point. So if you look at a platform, it also looks horizontal, right? You've got various different services, and I'll just go back to this, right? You have various different services in the middle: maps, alerting, billing, identity, and so forth. We don't just build these services in advance so that at some point in the future, a product might use them. We build these shared services and augment these shared services on a vertical pattern. So if a specific product needs a new feature and that feature calls out a new capability of the map, that is when we will build that new capability. Because in this case, we make sure that our shared services capability is enhanced to serve a product at that time, at the time that it's needed. We picked one primary language. We were really, I'd say, thinking this aspect quite a bit, because in such a scale of an organization, different teams come with different capabilities on different languages. So some teams were building in C#, some teams building in C++ and other languages, and some teams were building in JavaScript or in TypeScript. We had to make a choice of whether or not we allow each team to build with the language that they felt comfortable with, or we pick a language and then have all of the teams pick that language and learn that and make sure that they master that. We are really happy with the fact that we picked one language as our primary language, and that was TypeScript. TypeScript, by the way, is a superset of JavaScript, a strongly typed JavaScript, which has been gaining popularity significantly over the past few years. And this is the language that we use. And interestingly, here, this is the first time in my career that the language that we use for the front end and the back end is identical. And that has also contributed to a lot of the speed gains that we've had, because our engineers can work on the front end and on the back end in a very easy way. We have some minimal number of exceptions. So we have some C++ code for in Fortran, modern Fortran, that is used for highly optimized simulation engine, and of course Python for data engineering and AI. Last kind of bullet point that I wanted to mention, we use what AWS refers to as a pool tenancy model, where our entire infrastructure is shared among all tenants, and we ensure that the separation of tenants is done through a very secure and robust authentication or authorization. So we do not need to create infrastructure as a new tenant or a customer signs up with our service. So with that, I'm going to talk about what can actually cause teams to be slower. Now, I'm not saying don't do these things, but I'm just saying think those through. So the first thing, and actually This is something that is fairly simple to understand. When an organization, especially this size, has low cloud knowledge density, so for example, organizations that are looking to move from one technology or moving from on-prem development or desktop or any kind of different type of development to SaaS, if the knowledge density, so the number of people that really have experience with building such solution is low, that will cause a significant slowdown in the ramp up. I know this because I've actually done this kind of transformation around 2014, where my teams were transitioning from very much embedded software development, on-prem development, to SaaS, cloud, and AWS. Back then, it was okay because competition was not yet all on AWS. Today, you should assume that your competition is very knowledgeable on SaaS. So you need to make sure that the cloud knowledge density is high uh, as you start this journey, the journey to SaaS. How do you identify that there is indeed such a case? You'll see that there's an excessive amount of proof of concept and spikes. Every new feature starts with a proof of concept. We need to figure out which database to use or which data store to use, which language to use, which service to use, and so forth. These are telltale signs that probably there isn't upskill required within the organization. Um, I'm happy to say that our entire organization right now is really honed in on cloud and SaaS. A good part, as I mentioned, of our engineers are AWS solutions architect and developer certified, and so forth. Over Polyglot, so I mentioned, so Polyglot is the ability to run different services with different languages. So in the past, when you go to an interview, right, one of the questions is, what's the value of microservice architecture? And one of the values was that Polyglot, you can run every service with different language, so every team can work in their language that they are comfortable with. Now, the reality is, and that's based on experience, is that when an organization is run too many languages, it actually significantly reduces the speed of the overall organization, because team members cannot move from one team to another. Services or code pieces cannot be shared between different teams or services, and services themselves cannot transition between different teams. So for maintenance and so forth. So it's really creating a slowdown. So be sure to look into the number of languages you have within the organization. Multi-region failover and expansion. So multi-region is the ability for a SaaS solution to fail over to a different region in case that region fails. So AWS, for example, has lots of regions, and within each region, there are availability zones. So each availability zone is a data center by itself. Usually, the cloud providers provide a fairly good availability zone failover. That said, sometimes, and you really need to think through whether or not you need that level of failover, companies require to do failover between regions. So, for example, failing over from a region in Oregon, for example, failing over to a region in Virginia, because you need that level of uptime. If you do that, that has a significant cost, and you really need to think that. The other thing is region expansion. This is something that actually we support. We do support a number of regions within AWS, so our software runs on different regions in order to support specific requirements that our customers have to be in region, or to be in a larger set of regions, and so forth. Next up is infrastructure management. As I mentioned, we use managed services as much as possible. Only when cost difference is very significant, I'd recommend to look into an unmanaged service. And when I say unmanaged service, I mean a service or a platform that you or your team is actually responsible to keep up. A large cluster, a large Spark cluster, a large data store, and so forth, things of that sort that you actually manage will create slowdown in your operation because you need to maintain those, you need to upgrade those, and you need to have people who understands the ins and out of that infrastructure. Multi-cloud and hybrid cloud. So these are the abilities to run your software with various clouds connected together or cloud connected to on-prem. Really think through if you need to do that. So running in multi-cloud, some companies look into that for a cost perspective or just as a preference or not to be stuck with one cloud and so forth. Remember that low cloud knowledge density? Immediately as an organization decides to go to another cloud provider, so for example, in addition to AWS, you decide to go to Azure and work on two clouds at the same time, you immediately reduce your cloud knowledge density within your organization. Because although, if you look from afar, the services look roughly the same, the security looks roughly the same, but when you dig into it, these are actual professions. A cloud provider is an actual profession for engineers. So be wary of these things. Cloud agnostic, and this is, I would say, becomes more rare as time goes by. This is the ability to run your SaaS solution on any given cloud provider for various reasons, for reasons to be able to be mobile between different clouds, to uh, get the best benefit and cost benefit between different clouds. I really recommend to really think hard on that because that is a significant time drain on the overall capability of building a SaaS platform. Not to say that this is not required in some rare cases, but do think through if you really need to do that, because at that point you lose a lot of the capabilities or the native capabilities that the cloud provider provides. So with that, I wanted to touch base on one last thing. What if you really need to move even faster than that? You are not in an enterprise level SaaS provider, SaaS solution provider, and you really need to move faster. You need to get a product out to market in a faster way. Is there a different way to do that? If you can kind of do something that is slightly less in the capabilities that you need to provide your customers. And yes, there is, and it's becoming more and more capable over time. And that is the low code, no code environment or trend that has been growing over the past few years significantly. Um, I'd say I'm sure that there are a lot of people right now listening to me and kind of are a little bit uncomfortable with this because they're saying, we've been building software and we've seen this in the past. We've seen low code, no code solutions in the past. They've never been able to really scale to what we need, really do everything that we need for our customers. I would say that gradually these solutions are becoming more and more capable, more and more scalable, and you need to pay attention because gradually they're going to take more and more center stage, allowing developers actually to deal with the more difficult pieces of the development ecosystems. So just a Gartner forecast that that organizations are increasingly turning to low-code development technologies to really fulfill the growing demand for speedy application delivery and really provide an ability to customize automation workflows. I do recommend looking into that. Gartner has a lot more information about how companies are embracing these types of development solutions that gradually are allowing them to move faster and faster. So a little bit about the ecosystem. The ecosystem is huge and it's growing. Some of the notable solutions that are out there, Bubble.io, for example, a complete, let's say, software as a service builder, drag and drop. It does have a steep learning curve. you really need to understand what you're doing. But Bubble is a viable solution, and startups are using that. They're using that to get to their MVP. They're using that to get to market fit. Adalo solution to build mobile applications. Airtable, a lot of people know Airtable, of course. Webflow, as soon as you say Webflow, people think about websites and so forth. But Webflow, if you combine that with a plugin or a component called MemberStack, you are able to build SaaS application with complex memberships and tenancy. Software is in that space as well. There are also no code backends starting to come up. Xano is one of them. There are a couple more as well that teams can build complete backends and APIs with low code or no code solutions. And of course, AI can't ignore the number of AI low code, no code solutions that are out there. Just the list is really long. AWS SageMaker, Canvas, one of them, Data IQ, Data Robot, and others, really allowing data analysts to create good AI solutions. So possible use cases, and I have to say these use cases are growing all the time. For example, seeking product market fit, so the ability to iterate very quickly on a product, to change features at a low cost as the market reacts to your solution, really is a good use case to that. Internal tooling, of course, so tooling that is geared towards internal customers within the organization. SaaS internal facing portals, so a lot of SaaS products have two sides to them. One is the side that the customers see, that usually gets the most scale, requires the most uptime, and so forth. There are internal facing portals like super admin or admin, and so forth that internal users within the company are using. It just runs on an API. Mobile applications, or I would say the more simple mobile applications, can be done, and low scale front end for sophisticated, unique services. I'll just recommend something as if you go to YouTube and just Google Bubble and ChatGPT, you'll see the number of solutions that people have come up with to create unique capabilities very quickly while connecting Bubble IO through the API for ChatGPT. So highly recommend to look into that. So those are low scale front end that you can build very quickly, where the back end and the services really requires most of your effort. So with that, I'll move into some questions.
Boaz, thank you so much for your time. I really appreciate this presentation. It was super insightful. Definitely going to be looking into some of those apps that you mentioned at the end, the no code tool, and even the no code backend. I thought that was really fascinating. I haven't heard that one yet, so excited to check it out. We are over our time, so I don't see any questions that have come in yet. I will ask you one question. Where can people connect with you? Are you Twitter, LinkedIn, email? What do you prefer?
LinkedIn is best. I'm on LinkedIn. Feel free to reach out.
Sounds good. I think I connected with you earlier, so I look forward to kind of keeping up with the things that you're doing. Any way that I can be of a resource, I really appreciate you joining us today.
Thank you very much. It was a pleasure.
Absolutely. Have a great day.
Thank you.